Now this sequences in series question from 2022. Interestingly, when correcting this was without doubt the worst answered question on the whole paper. Okay, not so much the first part, but the part B, 1 and 2, were really, really poorly answered, and like they had the option to skip this question, and this was the most skipped question. Even though you would see in a second how there was actually loads of marks going for relatively simple stuff in this. Now, this first part A here, it's an interesting looking question, okay, and it's one that doesn't come up very often, right? Just very briefly, if you look at 2018, so it's not the part A but the part B. It's kind of a peculiar looking question. It doesn't really look like anything. It doesn't look like anything you might have done in relation to arithmetic sequences or geometric sequences. So it's tricky enough to see how would you approach this question. But let's have a look at it anyway. Okay, so basically what it translates as is you have your first term here. You have your second term, which is 64. And what it says is that the next term is always the current term divided by the term before that. Okay, and the square root of your answer then. Okay, so we want to find the third term. So it's saying that if you want the third term, well, it's the second term divided by the term before that, which is the first term, and we get the square root of our answer. Right? So a lot of people, when answering this, did quite well in getting this much. Okay, and then they simplified it down to root 32. But the thing is then they want it in the form 2 to the power p. So this is where our rules of indices come. It's a 10-mark question, but unfortunately if you only got as far as this, you only got 4 marks out of the 10, right? So really the rules of indices is where most of the marks are going from. And a lot of people just typed root 32 into their calculator, and I think they got 4 root 2 and left it as that, which is no good to you, okay? So you need to be aware of your rules of indices, and anybody who is familiar with it will know straight away that, well, 32 is 2 to the power of 5, and the square root is the same as to the power of a half. So 2 to the power of 5 to the power of a half is the same as 2 to the power of 5 over 2. Okay, so that was your 10 marks there for that. Part B then was the worst answered question, as I said, right? And I'll show you why in a second, but let's see, again, it was 10 marks. Let's see how you would get 4 marks in this. Okay, and interestingly, you've got 4. Look at it's a kind of a substitution technique that comes up. It doesn't appear a lot in the book, but it does come up quite a bit, right? Where when you're dealing with exponentials or indices or anything complicated like that, sometimes it's good to take the complicated thing and substitute in y or x or a or b or anything like that. Okay, so instead of having 5e to the power k, you could just have 5y. Okay, 13 stays the same. Now the problem here is with this 5e to the power minus k, that doesn't say anything about y, but if you know your rules of indices, you will know that 5e to the power minus k is the same as 5 over e to the power of k. That's how we deal with that. So we can change 5 over e to the power of k now to 5 over y. So now instead of this, we can put 5 over y. 13, the second term, stays the same. And look, we can change 5e to the power of k to just 5y. So now these are our first, second and third terms in terms of y. Now just doing that much actually got you 4 marks out of 10. Okay, and probably shouldn't tell you this, but even if you made the criminal error of starting with this and just substituting e to the power k in here instead of y, that actually got you 4 marks out of 10 as well, even though it didn't help you at all. Any substitution, correct substitution, actually gave you 4 marks. Right, so you can see you can pick up marks easily enough from this. So now we have our first, second and third terms in terms of y. Okay, now what are we going to do to solve this problem? All right, so what we do is we use a kind of an underappreciated rule of arithmetic sequences. Okay, and that's this rule here. Okay, so let's just examine this a second. If you take a very simple arithmetic sequence, you know full well that the second term, t2, minus the first term is 3. And that has to be equal to the third term minus the second term, and the fourth term minus the third term. It's the common difference, right? One term subtracted by the term before it will always give you the common difference, so therefore they must be the same. Okay, so how do we use that in this case? Well, if we take the second term here, which is 13, and subtract the first term, it has to be equal to the third term minus the second term, which is where we get this equation here. Okay, and once you have this equation, then it's just algebra then after that, right? So we're just solving this. Just be careful dealing with the y underneath the line here. Multiply everything by y, and we end up with this. Simplify it then, and we end up with what we were looking for here. Okay, so quite a clever question. 4 marks for just doing this. This was the bit that very few people spotted. Okay, I would say maybe less than 10% of people spotted that, and then your algebra at the end was quite easy. Now let me just very quickly show you a very interesting alternate method to this. Okay, and I call it interesting because it wasn't even on the marking scheme. right? And yet there were a handful of people who tried it this way, okay, and got full marks for it. You could actually use the arithmetic sequence formula for this, right? So this is our arithmetic sequence formula, right? What do we know about it? Well, A is your first term, that's 5 over y. D is your common difference. So D in this case would be the third term minus the second term. Now you could pick the second term minus the first term as well, but the common difference in this case is the difference between the two terms. So the trick here is if we found the third term, okay, well, how do we usually find the third term? Well, what do we know the third term is? Well, it's 5e to the power k, or 5y is a better one to use. And how do we use this then to find the third term? Well, we sub in a, we sub in d, and we sub in 3 instead of that. So this is our third term. This is also our third term, so we can actually put that equal to that. Right? And when we do that, we can actually simplify that very easily. Right? So 3 minus 1 is 2. Multiply everything by y to get rid of this y underneath the line here. See the way I multiply that 2 by y, multiply that by y, and we're left with that. Multiply out the brackets, and lo and behold, we get what we were asked to prove. Right? It's a very clever way of doing this question as well, and that would have got you 10 marks as well. Now, finally then, so this looked like a very hard question, okay? But we're basically just asked to solve for k in this case, right? But then they say something down here about getting in the form ln of p or minus ln of p. And I'll show you what that means in a second. But this was worth 10 marks, right? Now, the first step here, even if you gave this to somebody in junior cert, and they wouldn't have a clue what ln of p is, they wouldn't know what e to the power of k is, but they'd probably take a stab in the dark and say, well, maybe I need to solve this, right? So we could use the guide number here if you wanted to, you can use the minus b formula here if you wanted to, you can use just a simple factorizing method to do this, but we end up with y equals a fifth and y equals a k, y equals 5. Now, if that's all you did, and you had a clue what to do here, you just left it, you just did that and stopped, you got 8 marks out of 10 for this by the marking scheme. Okay, so doing something that a junior cert higher level student would be able to do actually got you 8 marks out of 10 here, and the vast majority of people left this blank. Now, how do we actually finish it off then? What's all this about? Well, we now take the fact that, okay, y equals e to the power of k, and we just substitute this e to the power of k back in here. Right, so I'll show you there are two solutions, and if we just replace this e to the power y with e to the power of k in both cases, now we just solve for e. And a well-prepared student will know that to solve an exponential function, you get the natural log of both sides, and we get ln of 5, and that's this solution here. Okay, now the problem was, what's the story with this minus here? Because if we get the natural log of both sides here, we're left with ln of 1 over 5. Okay, now where does the minus come from? Well, we can change 1 over 5 to 5 to the power minus 1 from our rules of indices, and from our rules of logs, if we want to get rid of this minus 1, can actually just bring it in front of the ln like that and leave it like that. So this was easy enough, but this was the bit that people got stuck with. But again, the marking scheme was very kind here. If you got this far, you got 8 marks. If you did this right and left it like that, or made a mess of this or something like this, you actually got 9 marks out of 10. And using this quite complicated bit down here actually only got you an extra 1 mark. Okay, so the marking scheme is very kind in this case.